All right, so we've got our vector group, so now we can move on to how we actually turn a procedural gradient into a usable component of our eye. And there's easy ways to do this, and there's hard ways to do it. The easiest way is, of course, you take a color ramp, you adjust the ramp. Let's see, we can fit that to the size of our iris object. All right, that gives us a mask of our iris. And now we can take this, let's make a pupil one. So same process, but slightly, oops, wrong one, slightly smaller. I'll zoom in as much as I can so that I grab the right stop. There we go. And we can take a color mix and use these as masks to control. Will be our white. We'll make our eye color a light blue. Second mask. Pupil color can be black for now. And we can also use this to create an outline around the outside of the iris. So it can be off the same texture because they're sharing that mapping. And for this one, if we add another stop, if I can select the right one, there we go. And now I'm zoomed in too much. And you might be getting the impression that these are actually a bit annoying to work with. And you are correct. Oh, no. There, that one. Okay. That's a black mask this time, so there we go. Now we have our iris color, iris outline, and pupil color areas that we can, now change to whatever we feel like. And we can, of course, put our textures into this, these inputs for this mask setup. And these, of course, correspond to our empty objects, so we can adjust that, and we'll rig those empties later. But this is annoying to work with, but more importantly, you can't make a reusable group out of it because there's no inputs on the color ramp to access these stops. So even though this is the easiest method on the surface, it's actually more annoying to work with if you're going to be reusing these tools and groups. So if you're not, and this is all you need, you can basically skip the rest of this video. But since this is about learning just as much as this is about actually building the setup, I will be teaching you the complex way. Let's take a look at the complete file and see the group we're going to be making. Note for anyone who already has this file is that I have made some changes. I changed the name and reorganized some of the nodes inside, but for the most part, it's the same. So what does this do? A gradient goes in, and then we have various convenient controls. We can adjust the position, which is referring to where the ramping takes place. So 0.5 is half the size of the full gradient. I keep going. In this case, 0 is the full size, and it's quite a bit larger than the plane we're looking at. And 1 will reduce it to 0 plus whatever additional thickness is set here. It then has a thickness control, which doesn't do a whole lot to this base, but matters for the line output. This lets us set the thickness of this line. It has inside and outside masks, so that we can get this either way. The outside mask is just the inside mask inverted. And then it also has some handy controls to put a little bit of feather on the edge here, a little bit of a gradient. And the size of that is relative to the thickness of the line. This isn't really intended to be used for large blur effects, just for a little bit of softening or anti-aliasing. And that also exists for the mask itself. Before we get into the guts of that group, let's start with some of the fundamentals. The alternative to color ramp is the map range node. We plug our gradient in there. Then we can see by working with the min and max values, we can get an effect that is very similar to ramping. In fact, it's not just similar, it's exactly identical to a two-stop color ramp. Here we have one stop at the position of 0.5, just like the from min, and we'll put this to 0.8, just like the from max, and it is exactly the same output. So let's try to really get our heads around exactly what these nodes are doing, which is basically the same thing. Once you switch to working with just numbers instead of the visual field, it can be difficult if you don't really have a mental model of what's happening. So the way we can think of this color ramp is that once it's moved to 0.5, we're telling it that black starts at 0.5, or halfway through the previous gradient. So now it used to take all the way out here to turn black, but now it's turning black right here. And now we're telling it white starts at 0.8. So the gradient is now between what was previously halfway through and 80% of the way through. And then past about here, it's pure white, and past there, it's pure black. And that's the same on this map range node, of course. Now we also have these 2 min and 2 max values. So let's try to understand what those are doing, although we're not really going to use them. Let's chain 2 of these. I'm just going to use this first one to resize the gradient to fit on my plane. So this is controlling essentially the input range. We're telling it the input range is 0 to 1, which is true. And then right now it's not changing anything because it's just remapping it from 0 to 1 to 0 to 1. So 0 stays 0, 1 stays 1. So now it's 0 to 0.1, which has a lightning effect, causing our gradient to expand. And of course that'll keep going. And if we turn this down, that has a darkening effect, because we're telling it, instead of being the gradient going to 0.1, or going to 1, it used to be white, now it's only 0.7 in that area. So this is a lot like if we took a color ramp and we changed the value on the stop. Again, it's actually the same thing. So the from min and max are the positions of 2 stops, and the to min and max are the same as the colors of the 2 stops. So if you get confused by the map range nodes, you could always model it out with a color ramp to understand what's going on. Now, map range and color ramp nodes also both have interpolation options. They don't have exactly the same ones, but they're similar. So right now, this is, of course, a linear interpolation. It goes from black to white in a consistent linear gradient. If we change this to ease, we get a slightly different gradient. It's a bit more blurry around the edges. And same for cardinal and B-spline. B-spline makes it go more into the black, I guess. I don't really understand the math behind these. I do know that you can make each of them out of math nodes if you need to. And on the map range node, we have linear, we have stepped, where we can control the number of steps. This is kind of I guess like a cell shader, a step cell shader style. And we have smooth step, which is similar to ease and cardinal, and smoother step. So that gives us a bit more of a blur. Let's see, is smooth step the same as ease? Slightly different, but similar. Now, these aren't the only way to sort of change the feel of your gradient, because linear gradients are a bit dull. You see them everywhere, and visually people kind of pick up on them. So another way you can get something like a different interpolation is just by taking some RGB curves, and you can drag this around a bit, and that's going to change at what point it's more light or more dark. So you can use this to add some character, especially if you're using these gradients for like color control rather than just masking. You could also do various things with math nodes themselves, but that's more complicated, so we'll leave that for somebody else to cover. So now that we understand that, let's take a look inside our finished group. And that looks pretty busy at a glance, but this is actually 3 distinct areas. So we've got our first map range node here, and all we have is some math manipulating the 2 inputs, the from min and max, which lets us set the position and the thickness, the offset from the initial position. So that's 1/3 of the group. Then our second third of the group here is actually the output of that, which goes through another map range, and this is just used to make that mask feather effect. And the third section of the group is the line and its feather effect. So each of these is pretty simple individually. Let's look at setting up our first control. I'm calling these position and thickness, with position being where the gradient turns to full black, and thickness being the distance before it goes to white. So in this case, the distance would be 0.5, and then the thickness is the difference of 0.1. So to set those up is pretty straightforward. We'll get ourselves a couple value nodes. We'll make our thickness 0.05 here. And there we go. We can adjust this to set where on our input gradient we get our hard edge, and then our distance here is effectively the ramp size. This is the distance between stops on a color ramp, effectively. Let's observe what happens as we use these values. For example, what happens when the total value of position plus thickness goes above 1? We'll set that to 1, and it disappears. We've got nothing now. And if we put it to 0.9 and then add more than 1, we still have something, but it's blurring out. And let's also take a look at, go back to 0.5 so it's easy to see. No thickness, it just turns black. But if we set a very low thickness like 0.001, then we actually have no thickness. And if we set a negative thickness, it actually inverts and goes the other way. So we know that we don't want it to be allowed to go negative, and we don't want it to be possible for the thickness to be 0 either. So let's add another control to limit that. And what we're going to use is a math node set on maximum. Now what maximum does is it says, of the two inputs, take whichever one is larger. So right now, the larger input is 0.5, so we're getting 0.5. If I turn this up, nothing changes until I go above 0.5, and then it's using the larger number. So we're going to use this to set a floor, which will be a low number, like 0.001. So now, even if we go to 0 or negative on our thickness input, it can't go below this number. And you could use even smaller than that if you wanted. But then we start to get some aliasing at the edges, depending on our resolution and the zoom. So I'm going to use 0.01 just to have that, just have no jagged edges. Because otherwise, if we rendered this at a high resolution, you could actually see that jaggedness. Right now, it's just my monitor resolution, and since I'm only in 1920 by 1080, that's okay. You know, you could do 2 or something like that. So you can choose this number for what you think you'll be doing with your monitor and render settings, but 0.01 is probably fine. Let's also check for if there's any issues on the minimum maximum values for our position. If we go to 1 or above, everything disappears, and that's fine, actually. And if we go lower, well, we stop being able to see what's happening because our sphere is bigger than our plane, so let's bump the iris scale down. Now we can go below 0, it's still fine, and then when we go negative, everything turns white. So we want to stop that. So let's get ourselves a maximum node on that too, with a value of 0. Now we've got both our values essentially locked into safe ranges. Let's back up. And now we want to think about where exactly do we want the thickness to take place. So I'm going to put my 3D cursor at the edge of our circle right now, and as I add thickness, it's essentially blurring inward. Is that really the behavior I want, or do I want it to blur equally to either side of the original edge? And this is up to you for what you want in your setup or how you want things to work, but I want to split it so that it keeps the original edge in the middle of the gradient. So the way we do that is we're going to take half of our thickness value and we'll keep this add, and then we'll also subtract half of it. So instead, and now we can see that the old edge is in the middle of that gradient. So instead of effectively just adding it, we subtracted half of it from one side and added half of it to the other, and that changes the 0 point. Now that that's working, let's chuck this into a group and get our setup going here. Also, I'm in 2.92 now, so the input UI has changed. It's a bit easier to adjust your inputs. Let's also make sure we set some reasonable minimum values on these. Since we're already controlling the minimums a bit with these maximum nodes, let's make sure that the values we set here line up reasonably. And of course, name the group. So this gives us our mask for what's inside. And of course, we can just invert that to get what's outside. So the other thing we need is to be able to make a line from this gradient. With a color ramp, that's pretty straightforward. We create a third stop and run into problems because we're not zoomed out enough. That actually needs to be white. There, now we can ramp this down to a line in relation to our original gradient, or use constant or whatever. But this takes 3 stops. As I mentioned earlier, the map range node only gives us a 2-stop color ramp. So how do we get this? I also mentioned earlier that you can do a lot of this stuff with various math nodes. In this case, we want absolute. Bam, line. That's because what the absolute node does is gives you absolute values, which is flipping the negative to positive. So if we turn this off and look at where the edge of our circle is, this is 0 counting up to positive 1. And then here is actually counting down to negatives because there is negative numbers caused by remapping our gradients. But if we adjust our position all the way down to 0, then that disappears. And that's because our original gradient starts here and everything outside here is 0. So there's nothing to flip for absolute to flip into positive. There has to be something for it to work with. And essentially, you need at least as much position as thickness. So with position of 0.1 and thickness of 0.1, we can see it's hitting the edge and cutting off before it can turn pure white. And if we turn the thickness down to, say, 0.05, then it works fine. Or if we turn the position up, then it's fine. Let's take a check on where exactly this line gets created. Let's stick the 3D cursor at the outer edge of our circle. And when we turn on absolute, we see that our line is at the outer edge of that circle. Now, of course, this is still a gradient, and we'll ramp that further in a moment. But first, let's think about what if we wanted our line to have the outer edge start where the edge of the circle was before. In other words, if we wanted this gradient from 1 to 0 to 1 to totally exist within the previous circle, to run from here to here, that can also be achieved pretty easily. All we have to do is subtract. And in this case, we'll subtract 1. And now we've accomplished that. And note that the overall thickness in visual space is the same. And now, actually, if we go to 0, we still have some problems, but as long as we're 0.1, yeah, that'll keep working. Another method is you can use map range here, and we can remap this from -1 to 1. And that gives us the same effect, but it actually shrinks everything. It shrinks the visual size by half. So I have this in the original file, and we may put it back later if we need to adjust where this line appears in relation to the original gradient. Now that we've got our gradient, let's go ahead and ramp that into a proper line. Use our map range node method again. Turn that down a bit, that up a bit. I'm going to set this to smoother step because I think that's a nicer looking sort of blur effect. And we'll control the amount of hardness the same way as before. A base input value, well, mostly the same way. Need a add and also a subtract. And what we're going to do is this value will be our, similar to thickness before, our feather amount. And we're going to subtract it from 1 here and add 1 to it here. So it will be the difference between these two values. Now, as we adjust that, we control how much of the gradient, how hard it is ramped, or effectively how much it is blurred. We want a nice small number. Now again, if we go negative or to 0, it gives us trouble. So let's go ahead and get ourselves a maximum node again, just to make sure we have a minimum value. Remember, maximum node gives you a minimum value because it takes the higher of the two. And now that's working nicely. Go ahead and chuck this into our group. I like to set a minimum and a maximum like 0 and 1 so that when scrubbing this, it gives me reasonable values. You can always type in a higher value than the minimum you set, or typing in a negative value doesn't do us any good because we have the maximum node here. But 0 to 1 is a good scrubbing range because part of the way I like to use these groups is just to be able to quickly adjust some value and get a quick doodle. A couple more things to consider. First, what color do we want this to be outputting? Right now, the line is black because we normally think of lines in terms of, well, being black line art or something. But actually, I want to make it white because this is actually supposed to be a mask for the line, and the line could be any color. So the proper convention is to have it be white. We could add an invert node for that, but we can actually just go ahead and flip the output on this map range, and now it's outputting in white. Another thing we want to check for is what happens when we turn the thickness down to 0. You'll note we still have a line, even though it should have disappeared at the 0 thickness. But that line is still there because of our minimum thickness here. Well, our maximum node making sure our minimum thickness. Yeah, that's confusing. So we don't really need to be able to set a minimum thickness of 0 line for this eye project, because if you don't want a line, you just wouldn't use this at all. But if you're using this method somewhere where you might keyframe these values or have, say, this be part of a larger group where for some setups you'll want a 0 value to eliminate this line, we're going to add some more controls to deal with that. Well, not so much a control as a condition. Let's get ourselves a math node and a less than. If our thickness input is less than a low number, 0.001, then we're going to do things differently. Mix RGB. So if this is, if the thickness value is less than 0.01, we'll get the second output, and if it's greater, we'll get the first output. So if it's greater, we'll get our regular lines, and otherwise, we'll just get black. And what that means now is, as this gets down to 0, it will eventually disappear. I think we can go ahead and make different outputs for these two now. And just to remind ourselves, when using this with the inside mask output, we can adjust the position and we can adjust the thickness, but we don't really have a way to adjust what this gradient is doing. We could, of course, ramp this again, but that's what our mask feather control is going to be for, that we'll set up now. We'll build the mask feather inside the group right away this time. This will also be based off a map range, so we're going to take our existing gradient and put it through another ramping effect. We'll want to copy this setup, as we're basically reproducing the same thing. This will be a new input. It's the same basic idea as the line feather. Guess we can just reuse this guy. So at 1, this is just our original gradient. If we have no thickness, mass feather does nothing because it's only ramping the gradient that's left over after the initial ramp. This way we could say have a larger thickness and still adjust it. So when the mass feather is at 1, we have the original gradient coming through, and as we turn it down, it hardens to nothing. And the same thing on the line, actually. So I'm going to set the default values for both these feathers to be 1, actually. But that's just personal preference. You can put these to whatever you think you're going to work with. Now we can make the third output of our group, which is simply an inversion of the inside mask. That is nice and straightforward. And we can start setting up a bit of the eye masks themselves, as we did originally with our color ramps. That can be the white. Let's go for a light blue for the original color. And we won't do the pupil yet, but let's get a line mask to black. And I'm going to go ahead and multiply this just to reduce the strength of that mask so we can watch what's going on with the interaction here, because we're going to need to do some corrections. When there's no feather on either, the outer edge of the mask and the inner edge of the line up exactly. But as we give the line feather, it opens up a gap, which if we turn this off, you can see. And if we feather this, it moves to meet it, but it's still giving us the same gap. So what we need is some sort of correction. Ideally, we'd like the outer edge of the iris to actually be in the middle of the line, regardless of the line's thickness. Oh, and just a little tip, when you're scrubbing values, if you hold shift, it changes the amount less, so that's handy to work with. So we either want to bring the edge of our inside mask out to here, or to bring the line in. In my original setup that I sent out, I had done it by adding here, which expands the inner mask. But I think a better way to do it is actually to subtract from the line so that the inner mask can stay consistent. We subtract 1 here, not -1, then it pulls our line back to beat the mask. We'll go ahead and make this a new control. Value 0 to 1, default to 1, and now it's easy to adjust where our line is relative. Of course, the way these controls have been set up, you can do this a lot of different ways. You could decouple the line thickness from the gradient thickness. I've just built this kind of as a demonstration. It's sort of built for purpose for the way I set up these eyes. So these controls made sense to me at the time, but you can certainly optimize this more if you feel like adding more nodes, now that you can understand how working with these different things actually goes. But for now, let's give ourselves a line thickness we might actually want. And it looks like the edge of our mask is lined up with our empty. So we can get rid of that and give ourselves a little bit of feather on the line. Maybe 0.35 will be good, just so that it's not too aliased. And we'll stop there for this video. In the next video, we'll be looking at setting up the area masks group. You can see this is based on the group we just made, and we have 2 uses of it, one for the iris and one for the pupil. And we're building a bunch of masks to define which area gets the iris color, what gets the pupil color, and various outlines. If you want to get this full setup, it is already available on my Patreon or on Gumroad, so consider picking it up to support me. And as you notice, as I rebuild this a second time, I am finding some things I want to change, so I will be putting updated versions of the files out for anybody who bought them already. Thanks, and see you next video.